How does our body absorb the medicines we take? That's a question that sparks our journey into the fascinating world of pharmacokinetics. Absorption is the first step, the initial process where the drug makes its way from the site of administration into our bloodstream, and it's far from a simple process. Let's take a closer look. You swallow a pill, and it travels down your esophagus, landing in your stomach. Here, the drug formulation comes into play. Is it a tablet designed to dissolve slowly or a liquid that is absorbed almost immediately? The design of the drug plays a crucial role in determining how quickly and efficiently it is absorbed. Next, we need to consider the route of administration. Oral ingestion is the most common but not the only way. Drugs can also be administered intravenously, intramuscularly, or even through inhalation. Each route has its own characteristics, affecting the speed and efficiency of absorption. For example, a drug injected directly into the bloodstream bypasses the digestive system entirely, leading to rapid absorption. But it's not all about the drug and its route. Our bodies play a significant role too. Physiological factors like blood flow, body temperature, and the pH level in our stomach can greatly impact absorption. For instance, a well-perfused organ, like the heart or liver, will absorb drugs more quickly than an organ with less blood flow. Keep in mind, absorption is not a guarantee. Some drugs may not be absorbed at all, while others might be absorbed only partially. This is where the concept of bioavailability comes into play, essentially measuring what percentage of the administered drug actually makes it into our bloodstream. While it might seem like a lot to take in, remember, absorption is just the beginning. It sets the stage for everything that follows, determining how a drug will interact within our bodies, how it will be distributed to different organs, how it will be metabolized, and eventually, how it will be excreted. Absorption sets the stage for how a drug will interact within our bodies. It's the first step, but certainly not the last, in the fascinating journey of a drug within our bodies. Once in the bloodstream, where does the drug go next? Welcome to the second chapter of our fascinating exploration. Distribution, the journey. Now that the drug has been absorbed into the bloodstream, it embarks on a remarkable voyage throughout the body. Just like a ship navigating the vast ocean, the drug must traverse the intricate network of veins and arteries in our bodies. But how does the drug know where to go? It's all about blood flow. Our heart, the epicenter of our circulatory system, pumps blood to every nook and cranny of our bodies. And it's this very flow of blood that carries the drug to its intended destination. Whether it's a remote cell in our toes or a neuron in our brains, the drug reaches its target thanks to the tireless work of our circulatory system. However, the drug isn't traveling alone. Along its journey, it interacts with various proteins in our blood. Proteins, especially albumin, are the unsung heroes in the process of drug distribution. They act like a taxi service for the drug, binding to it and carrying it to its destination. This binding also controls the drug's concentration in the blood. Only a fraction of the drug is free to interact with body tissues, while the rest remains bound to these proteins. But why is this binding crucial? Well, the proportion of free and bound drug determines the drug's effectiveness. Too much binding, and the drug may not reach its target tissues in sufficient amounts. Too little, and it may lead to toxicity. It's a delicate dance, one that is vital for the drug's ultimate goal: therapeutic effect. So, the distribution of a drug isn't merely a matter of transportation, it's a rich interplay of blood flow, protein binding, and careful control of drug concentration. It's a journey characterized by precision, balance, and a remarkable understanding of our body's inner workings. The drug's journey through our bodies is complex and vital to its effectiveness. So the next time you take a medication, take a moment to appreciate the intricate journey it embarks on to keep us healthy. Did you know that our bodies can transform medicines we take? A phenomenon we call metabolism, or more precisely, biotransformation. This transformative process is like a meticulous artist, reshaping and refining substances within our bodies, including the medicines we consume. The liver plays the starring role in this process. Picture the liver as an industrious factory bustling with activity. It's here that most drugs undergo their metamorphosis. The liver's enzymes, particularly those from the cytochrome P450 family, catalyze chemical reactions that modify these drugs. But why does this happen? Well, the body is all about balance and efficiency. the liver transforms drugs into more water-soluble forms. This transformation makes it easier for our bodies to excrete these substances. Simply put, it's the body's way of tidying up, turning potentially harmful substances into forms that are easier to handle and dispose of. However, this transformation can have a significant impact on the drug's activity. Sometimes, the metabolites, or the products of metabolism, might be inactive, significantly reducing the drug's effect. This is what we call drug inactivation. But at other times, these metabolites might be just as active, or even more active than the original drug, leading to a prolonged or enhanced effect. This is what we refer to as active metabolites. It's also worth noting that not all drugs are metabolized in the same way. Factors like age, genetics, disease states, and even diet can influence how a drug is metabolized. This is why the same drug can have different effects on different individuals. So imagine a drug as a story. The absorption is the introduction, the distribution is the plot, and the metabolism is the climax where the story takes an unexpected turn. It's a fascinating process, one that underscores the complexity and adaptability of our bodies. Metabolism is the body's way of making drugs more manageable. It's a crucial step in the journey of a drug, a transformative process that ensures our bodies can effectively and safely handle the medicines we take. How does the body get rid of these drugs, you might ask? Well, buckle up, because we're about to dive into the fascinating world of excretion, the unsung hero of our body's drug processing system. Excretion is the process by which our bodies remove the metabolites of drugs, and it's the final step in a drug's journey through our bodies. This is where our bodies say a polite but firm, "Thank you for your services, but it's time to go." Now, the kidneys are the main characters in this story. They're like the bouncers of the body, deciding who stays and who leaves. Most drugs, once they've been metabolized, are water-soluble, which makes them prime candidates for renal excretion. This is a fancy way of saying they get peed out. The kidneys filter our blood, and any unwanted substances, like our metabolized drugs, get bundled up into urine and sent on their way. But let's not forget about the supporting characters in this story: bile, sweat, and breath. These guys also play key roles in drug excretion. Some drugs are excreted in bile, a substance produced by the liver. This bile is then sent to the intestines and leaves the body the old-fashioned way, through feces. Meanwhile, sweat and breath are also minor routes of excretion, but every little bit helps when it comes to clearing drugs from our system. So, to sum up, excretion is the body's way of clearing out the remnants of drugs after they've done their job. It's a crucial process that keeps our bodies in balance and ensures we're not holding onto substances longer than necessary. And while it might not be the most glamorous part of the process, it's certainly one of the most important. And that, my friends, is the magic of excretion. From the kidneys filtering out water-soluble metabolites, to the liver producing bile, to sweat and breath doing their part, it's a team effort to keep our bodies clean and functioning smoothly. Excretion is the final stop in a drug's journey through our bodies. A vital process, it's like the body's own waste management system, ensuring that we're ready and raring for whatever comes next. Why is it important to understand these mechanisms, you might ask? Well, absorption, distribution, metabolism, and excretion. These four processes are not isolated events. Rather, they are interconnected, existing in a dynamic relationship that collectively determines a drug's impact on the body. Think of it like a symphony, each instrument playing its part. Absorption is the entrance, the first note that starts the melody. Distribution is the journey, the crescendo and decrescendo of the piece. Metabolism is the transformation, the harmony that adds depth to the music. And excretion is the exit, the final note that brings the symphony to a close. In the body, these processes work together, influencing one another. The rate and extent of absorption can affect how quickly and how much of the drug is distributed throughout the body. In turn, the processes of metabolism and excretion can impact how long the drug remains active and when it leaves the body. Understanding these processes is not just interesting scientific trivia. For pharmacists, it's crucial in optimizing drug therapy. It helps in predicting how a drug will behave in the body, how it can be best administered, and how it might interact with other substances. It informs decisions about dosage, timing, and potential side effects. A deep understanding of these processes is fundamental in the field of pharmacy. It's a fascinating world, where science meets practice, and where knowledge can make a real difference in people's lives. That brings us to the end of our journey through the body's handling of drugs. We've explored the intricate dance of absorption, distribution, metabolism, and excretion. Each step is vital, influencing how effectively a medication works. From a drug's entry into the body to its eventual exit, the journey is complex but fascinating. Knowledge of these processes is key to understanding the full impact of medications. Remember, every drug's journey is a complex interplay of absorption, distribution, metabolism, and excretion. Subscribe for more insightful content like this.